Hey, good morning, guys. So this is sheet number 8, how to do sheet number 8. If you don't have these notes on synthesis, decomposition, single displacement, and double displacement, then get these in your notes right now. Pause the screencast right now and write down synthesis, element plus an element, arrow. Decomposition, compound, arrow, or compound plus heat, arrow. Single displacement, element plus compound, and double displacement, compound plus a compound. Okay, so we have notes for all 4 of these. So that's what we did last week, and hopefully you guys have had enough practice for each one of these so that we can continue on, and once we identify it, then you know how to finish the product. So this is actually called predicting products in chemistry. Okay? Everything on the right-hand side are products. Everything on the left-hand side are reactants, in case you didn't know that already. So reactants on the left-hand side, products on the right-hand side. So if we have 2 things that we're going to add together, like an element plus an element, then of course we are talking about a synthesis reaction. Now, the key to this is knowing, obviously, at the most basic level when you're looking at something, whether it's an element or a compound. Okay, if it's an element, that means it only has 1 capital letter. If it has more than 1 capital letter, okay, then it is not just an element. So something like, it's okay to have a number like H2 plus O2. Okay, those numbers do not mean that's a compound. It means it's a molecule. It's more than 1 atom, but those atoms are the same though, which make it still just an element. Okay, I hope I'm clarifying some misunderstandings that you might have. And if not, then this is just, you can fast forward this part. So for a compound, obviously that means that there's more than 1. Oops, capital letter. Okay, now we obviously know that H2O is a compound. We have 2 capital letters, we have the H and the O. Okay, sometimes it doesn't have to be just 2 capital letters. It can be something as extreme as 4 capital letters. C2H3O2 is a pretty common polyatomic ion. That's acetate, so this is calcium acetate. And we don't have a rule for breaking up acetate, but we do have a rule for breaking up calcium sulfate. We do have a rule for breaking up calcium carbonate. So all of those things that you remember from before for the decomposition reactions. SD is just as easy to identify if you have an element plus a compound, or it could be a compound plus an element. It does not have to be exactly in this order. Okay, so you can switch these things around. The plus does kind of mean algebraically that they can be reversed. Okay, it doesn't mean that you're going to take the compound plus the element and make an even bigger compound. That's not what the plus means. It doesn't mean that it's completely additive, like 6 plus 7 is 13, but it does mean that you can have the compound come first and the element second, and that's completely okay. Okay, so let's keep going and take a look at a couple of our examples. Now, I'm assuming that you have the notes for synthesis, for decomposition, for single displacement, and for double displacement already done. Okay, that you know where to look for those notes. You've practiced them already. So all I'm going to do is, in the beginning here, for the first 4, is I'm going to write down what type of reaction it is by looking at this stuff in the reactants. So using the notes from the previous page. So number 1 is copper 2 sulfate. I know that because sulfate has a -2, which means that this copper must be a +2, which is where the copper 2 comes from. Not a subscript, it comes from the charge of copper. And, excuse me, and notice I have plus heat there. This is a dead giveaway, always a dead giveaway. So if I'm identifying the type of reaction, which I am asking you to do for sheet number 8, it does say that in the directions. Okay, so for number 1, is a decomposition, because plus heat is a dead giveaway for a decomposition. Not all of them say plus heat, but you should have a compound and then plus heat and the arrow, or just a compound an arrow. And those are two ways that you can tell that's a decomposition reaction. So it's just a decomposition reaction, and not only that, it is a sulfate decomposition reaction. So you look to see if copper is a group 1 metal or not, and I'm not going to go through the rest of that for you, because you should be able to look up what happens to a sulfate. Okay, how about number 2? What does number 2 look like then? So number 2 looks like one capital letter and more than one capital letter. So that makes this a single displacement reaction. So then you have to go check to see if silver is a metal, which of course it is, then it's going to kick out the hydrogen, the positive part. Okay, and then you go ahead and check the numbers, and the numbers look something like this, and then you can determine whether that's going to happen or not. If it doesn't happen, you put a no reaction. If it does happen, then go back to symbols and charges and make the compound with Ag and SO4. You have to crisscross. Okay, let's go down one more. So now we know it's a single displacement. We know where to look in the notes. So for number 3, now I have a compound plus a compound. And that means that it's definitely double displacement. Okay, we have two choices for the double displacement. It's either precipitate double displacement or it's an acid-base double displacement. Okay, in this case here I have a base and I have an acid, so this is an acid-base double displacement. You can read the notes and figure out how to do that. Don't forget that all double displacements follow the same pattern. The A, B on one side, C, D. Okay, so AB plus CD yields, and then we switch the negatives, AD and CB. Okay, and you guys can do that. Go back to symbols and charges on the right-hand side. Number 4, let's keep going. Number 4 is, again, a plus heat. So that means automatically this is a decomposition. And then, again, I'm looking to see what it says for sulfate. So the negative part is what tells us what type of decomposition it is. And then I check to see if it's, group 1 or group 2 metal. Okay, I recommend that you give those a try. And as a matter of fact, I would, if I were you, I would go through and try and figure out, just looking at them, what types of reactions they are. So your choices are S, D, SD, and DD. Okay, get used to identifying those types of things. It's sheet number 8 and sheet number 9 are going to be almost identical in the directions. Sheet 9 is a little bit more difficult, I think, but not by much. So what do you think this is? It looks like an element and it looks like a compound, which of course would be SD. So you have to look to see, is nickel a metal? Of course it is. Okay, what's the number for nickel then? Because for metals, we take a look at the activity series and we check to see if it works. Okay, number 6, I got A plus BC, which means, of course, this is another single displacement. This one's with water. So there's a specific rule for that. Check to see if it works. Here, number 7 is our first one, where we have an element plus an element. So that makes this, of course, a synthesis. Okay, number 8, again, I have a compound plus a compound, which means double displacement. And then we just follow our A, B, C, D. Okay? All right. Let's go through and take just a quick look. We might as well answer one or two of these and make sure that you got them right. So the first part here for the copper sulfate is I'm taking a look in the notes for the copper sulfate. And I noticed that for sulfates it says for group 1 and group 2 metals that this is a no reaction. Is copper a group 1 or group 2 metal? And we know that it's not. It's a transition metal, which means that this does work. So what are the products for a sulfate? If you read the directions, it tells you specifically for a sulfate that's not group 1 or group 2, then we get sulfur trioxide plus the metal oxide. When I write down sulfur trioxide, I can write down SO3 without symbols and charges, no charges for a prefix because I saw trioxide. So that means it's definitely a prefix. And then when I go metal oxide, now I do need symbols and charges because this is an ionic compound with a metal, and then the non-metal is, of course, oxide. Oxide is always a -2. Always a -2 unless it says peroxide, then it's different, and we'll go over that. So now I got +2, -2, so I can get rid of that. And I go back through. Once I have the symbols and charges and crisscrossed, which I just did that by the +2 and -2 canceling, then I go back and balance. I have 1 Cu and 1 Cu, 1 S, 1 S, 4 oxygens. I have 3 here plus 1 right there equals 4. So I'm actually balanced. So the first one was pretty simple, okay, if you know what the products are. The next one is even easier. This is a metal plus acid, okay? Metal plus acid is exactly like a metal plus salt. So I check the numbers. The numbers meaning the activity series for silver is 24, which means it's very unreactive. And for hydrogen it's always 18. And 24 is higher than 18, which means silver is too non-reactive to react with acid. That's a strange way to say it. Silver is not reactive enough to react with acid. So this is actually a no reaction, which is easy because you don't have to crisscross, you don't have to balance. It's just NR. Nothing changes. The silver does not change. Let's do one example of a double displacement, and then I'm going to let you guys finish the rest of these. So here I have sodium hydroxide. Oh boy.